Students, now we are going to see the course signals and system. Under that, the topic is Laplace transform. On completion of the Laplace transform, the students can able to know the applications of Laplace transform, and they can solve the ordinary differential equations using Laplace transform. Laplace transform that can be divided into two: bilateral Laplace transform and unilateral Laplace transform. The bilateral Laplace transform, let x of t be a continuous time signal defined for all values of t. Let x of s be a Laplace transform of x of t. That is, Laplace transform of x of t is x of s, which is equal to integral minus infinity to infinity x of t e power minus st into dt. In one-sided or unilateral Laplace transform, the integration limit is 0 to infinity, and the x of t of the continuous time signal is defined for t values greater than or equal to 0. That means the unilateral Laplace transform is applicable only on the causal signal. So Laplace transform of x of t is x of s, that is integral 0 to infinity x of t e power minus st into dt. Inverse Laplace transform, the S domain signal x of s can be transformed to time domain signal x of t using inverse Laplace transform. The inverse Laplace transform of x of s is defined as L inverse of x of s, that is equal to x of t equal to 1 by 2 pi j integral s equal to sigma minus j omega to sigma plus j omega x of s e power st into ds. Here the x of s exists only if integral minus infinity to infinity x of t e power minus sigma t into dt value is less than infinity. That means it is absolutely integrable. Existence of Laplace transform. The necessary and the sufficient condition for existence of Laplace transform are x of t should be continuous in the given closed interval, and x of t must be absolutely integrable. Problems: find the unilateral Laplace transform of the following signal. And the first signal is x of t is del of t, that is impulse signal. So x of s is equal to integral 0 to infinity x of t e power minus st into dt. Substitute the x of t, so integral 0 to infinity del of t e power minus st into dt. So del of t is an impulse signal. It holds the amplitude 1 if t is equal to 0. So the term is del of 0 e power 0 minus s into 0. The net value is equal to 1. So Laplace transform of unit impulse is equal to 1. Then x of t equal to u of t. U of t is a unit step signal. So x of s equal to integral 0 to infinity x of t e power minus st into dt. So substitute the x of t equal to u of t. So integral 0 to infinity u of t e power minus st into dt. U of t, it holds the amplitude of 1 if the time is between 0 to infinity. So the integration becomes integral 0 to infinity 1 into e power minus st into dt. Integrate this. So e power minus st by minus s, limit is 0 to infinity. Substitute the limit minus infinity. E power minus infinity is 0. So minus of e power minus infinity by s plus e power 0 by s. E power 0 value is 1. So the answer is 1 by s. Find the Laplace transform of x of t equal to e power at into u of t. So the signal is multiplied with u of t. So the given transformation is unilateral Laplace transform. So integration limit is 0 to infinity x of t e power minus st into dt. Substitute the x of t value is e power at. So integral 0 to infinity e power at e power minus st into dt. Now combine both the exponential term. So e power minus of s plus a into t into dt. Integrate this. E power minus of e power s minus a into t divided by minus of s minus a. Limit is 0 to infinity. Substitute the limits and you are getting 1 by s plus a. Next problem, find the Laplace transform of x of t equal to 4 e power minus 2t cos phi t minus 6 e power 3t sin phi t into u of t. So solution, this problem is solved by using the general expression formulas. So Laplace transform of e power minus at cos omega t is s plus a by s plus a the whole square plus omega square. Similarly, Laplace transform of e power minus at into sin omega t is omega by s plus a the whole square plus omega square. So here Laplace transform of e power minus 2t cos phi t is s plus 2 by s plus 2 the whole square plus phi square. Then simplify this. Then next is Laplace transform of 4 e power minus 2t cos phi t is 4 s plus 2 by s plus 2 the whole square by plus 25. So similarly, Laplace transform of e power 3t sin phi t is 5 divided by s minus 3 the whole square plus phi square. So Laplace transform of 6 e power 3t sin phi t is 6 into 5, multiplication of 6 and 5 divided by s minus 3 the whole square plus phi square, that is equal to 30 by s minus 3 the whole square plus 25. Now substitute both the values in the Laplace transform of the given signal.